Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers AQA Paper 2. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find the link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on, and more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it.
Question 1. The equation of a line is y is equal to 2x minus 1. Circle the point that is the intercept with the y-axis. Okay, well, equations are always of the form y equals mx plus c. So the m value is 2 and the c value, or the y-intercept, is minus 1. Now that means that this line is going to pass through the y-axis at minus 1 with a gradient of 2. So that point there where it passes the y-axis, so this is the point 0, minus 1, that one there. Question 4. One of these is the sketch of y equals x cubed plus 2. Which one? Circle the correct letter. Well, this equation is a cubic curve, and cubics tend to look like this. They start low, they change direction, and then change direction again, and change and end high. Sometimes they're less pronounced in the middle, like this one. And this number on the end here, the constant, is still our y-intercept, so we're going to be expecting this graph to cross the axes at 2. So which one of the graphs has a kind of S-shaped curve and it passes through the y-axis at plus 2? It's this one here, look.
Question 5, written as the product of prime factors, 12,600 is 2 cubed times 3 squared times 5 squared times 7. And 14,112 is 2 to the power 5 times 3 squared times 7 squared. Work out the highest common factor of those two numbers. Give your answer as an integer. Well, we can easily work out HCFs of two numbers if we've got them in factor form like this. I'm just going to write them out in expanded prime factor form so we can see all of the individual factors clearly. Okay, so that's 12,600, and then 14,112. That's 2 times 2 times 2 times 2 times 2 times 3 times 3 times 7 times 7. Okay, so the HCF will be made up of all the terms that are in both. Okay, so I've got a 2 in both here. I've got a 2 in both here. I've got another 2 in both here. And I've got more 2's in the bottom number. I haven't got any more to match it in the top one. I've got 2 3's in both, 3's in both, and I've got a 7 in both. Okay? So altogether, what I've got in both is 2, 2, 2, 3, 3, 7. Okay, and then if I multiply those all together, that is going to give me my HCF. So 2 times 2 times 2 times 3 times 3 times 7. What's that then? 2 times 2 times 2 times 3 times 3 times 7. That comes out to be 504.
Okay, so that's my HCF 504. Question 6. Beth drives 200 miles in 4 hours. She drives the first 18 miles at an average speed of 36 miles per hour. Work out the average speed of the rest of the journey. So we've got a question here involving distance, speed and time. You can remember how these are related using this triangle. It's the DST triangle. D at the top, S and then T. They're alphabetically listed, aren't they? D, then S and T. And this tells you how those three things are related to each other. Okay, now we're going to look at this journey in 3 different ways. First off, we're going to look at the whole journey, so the total journey. Now the total journey, what is D, what is S, what is T? Well, we've got the distance, which is 200 miles. We don't have the speed, but we have the time, which is 4 hours. But we can find S then using the other two. So we just cross off, kind of stick your finger on top of the one you're trying to find, in this case S. And then the triangle tells you what to do with the other two. So average speed, oops, let's write in blue. Average speed is distance traveled divided by time taken. In this case, it's going to be 200 divided by 4, which is 50, isn't it? 50 miles per hour. Okay, so that's the average speed for the whole journey. Right, so does that help us? What does the next part says? It says she drives the first 18 miles at an average speed of 36. So I'm going to write this. This is the stage 1 then of the journey. There's 2-stage journey, isn't there? And the first section, we know D and we know S, but we don't know T. So let's find T. Let's see if that helps. So we know that the distance is 18. We know that the speed is 36. So what we want to find is time. So again, going back to the DST triangle, if you cover up T, you can see that time is going to be distance divided by speed. Okay, which is going to be 18 divided by 36, which looks like a half to me, 0.5. So what's the units of that then? So this is time in hours then, isn't it? So 0.5 hours, that's half an hour or 30 minutes. Okay, I'm just going to leave it in hours for now. Okay, so then stage 2 of the journey, what do we know about this stage? Do we know anything about it? We know the total distance travelled was 200. And we know that distance travelled in stage 1 was 18. So the distance travelled in stage 2 then is going to be 200 minus 18. And isn't that's going to be 182 miles. Do we know the speed? No, that's what we're trying to find. Do we know the time? Well, again, we know that the time for the whole journey was 4 hours. We've just calculated the time for stage 1 to be half an hour. So that leaves us with 4 subtract half an hour. That leaves us with 3.5 hours then, doesn't it? For the second stage of the journey. Okay, and then we want to find the average speed of this part of the journey. So again, from the triangle, cover up S, it tells me that speed equals distance over time, which is now 182 divided by 3.5. Okay, time to reach for a calculator, I think. So 182 divided by 3.5 comes out to be 52. Okay, so that's 52 miles per hour then. Question 8. Doug owes an amount of £600. He wants to pay off this amount in 5 months. He says, each month I will pay back 20% of the amount I still owe. Show working to check if his method is correct. I don't think this is going to work, Doug. If you're just paying back 20% of what you still owe, this is a kind of never-ending sum, isn't it? Basically, it's like compound interest, isn't it? So you've got, for percentages, final, original, multiplier. The final is what we're trying to find here. The original is 600, and the multiplier, so if he's paying back 20%, then he's retaining 80% of the value then, isn't he? So you're basically times him through by 0.8 each time. So after 5 months of paying back 20%, your final then equals original times multiplier, which is 600 times 0.8, but we're doing this 5 times, aren't we? So it's to the power of 5. So after 5 months, how much will be left? 600 times 0.8 to the power of 5. That gives me £196.61. That's remaining to be paid, isn't it? So he has not cleared the £600. Okay, I think I'm just going to sign off like that. So I've shown it, haven't I?
Question 9. The diagram shows the scale drawing of a sandpit ABCD. It also shows the arc of all points in the sandpit that are 80 centimeters from the corner A. We're told that the scale of 1 centimeter represents 20 centimeters. A game is played by throwing a ball into the sandpit. Points may be scored when the ball lands in the sandpit. 1 point if the ball lands within the 80 centimeters of corner A, and 1 point if the ball is closer to side AB than to side AD, and 1 point if the ball is closer to corner A than it is to corner B. By completing the construction, find and shade the regions where 2 points can be scored. Show all of your construction lines. Right, now the first construction is already done for us, isn't it? So the one where it has to be within 80 centimeters from corner A, that circle has already been drawn. It's that arc, isn't it, there? Yeah, so you can see this one is 4 centimeters, which is 80, so that has already been done. So I'm going to move on to the second one, which says 1 point if the ball is closer to side AB than AD. Okay, so the construction that we need for the points that are equidistant from 2 lines is the angle bisector of those 2 lines. Okay, so what we're going to have to do is construct the angle bisector. Now normally I would put the compass at A first and do an arc that cuts both, but we've already got this handy arc already drawn, so I'm just going to use those 2 points to mark my cross in the middle to make the angle bisector. Okay, so that makes my job a little bit easier. So sticking on either end, we're drawing a little arc, and then where they cross, that is going to be where my angle bisector is going to go through. Okay, so the line I'm drawing are all the points that are equidistant away from those 2 lines. So clearly if I want it to be closer to AB, then I want it to be below that line there then. Right, next construction. The point of if the ball lies closer to A than to B. So the points that are equidistant from 2 given points A and B are going to be the perpendicular bisector of that line. Okay, so in order to draw a perpendicular bisector, I'm going to set my compass to a little bit over halfway between those 2 points, and I'm going to draw an arc with the compass based at B. Okay, a bit of a semicircle going on there, and then switch over to A, and I'm going to draw another semicircle. We should find that they meet in 2 places. Okay, it's a little bit off screen. Let me just push it up a bit. So drawing a line through where those 2 arcs crossed, that's going to be my perpendicular bisector. So all of those points are equidistant from A and B. Okay, so if we want the points that are closer to A, then I want the points to the left of that line. As I said earlier,
if I want the points that are closer to the line AB than the points AD, then I want those below the angle bisector. Okay. Now in this case, I then want the ones outside of the circle then, because if it's inside the circle, it'll be worth 3 points. But I want to highlight the ones that are just worth 2 points. So inside the circle would meet all 3 conditions, and then they'd be worth 3 points. Now, is there any other place which is worth 2 points? This one here is, isn't it? Because that's inside the circle and closer to A than to B, so that's worth 2 points. What other regions have we got? This one up here is only worth one point because it's closer to A than B, but doesn't meet any of the other conditions. And that one down there is worth 1 because it's closer to AB than AD, and the one at the top is worth 0 because it doesn't meet any of the conditions. Right, so they're the 2 regions that I want, and I've shaded both, so that's job done. Let's move on. Question 11. Joe and Kyle share an amount of money in the ratio 7 to n. Joe gets 35% of the money. Work out the value of n. Okay, so we know that Joe to Kyle is in the ratio of 7 to n. Now, Joe gets 35% of the money. So what percentage would be left then for Kyle? Kyle's going to get the rest then, isn't he? So if I've got 100% and I let Joe have 35% of it, then Kyle is going to get 65% of it. Okay? Can you see that that is, well, the relationship between these 2 numbers? That's 5 times bigger, isn't it? Okay? So then n, if I multiply n by 5, I'm going to get 65. In other words, n then must be 65 divided by 5. 65 divided by 5 is 13, so n is 13. Question 11. Use trigonometry to work out the size of angle x. Okay, right, so trigonometry is a right angled triangle, so it's about Socateur, isn't it? Is that how you remember it? Now, easiest thing to do is just label up the sides first. Here's my angle down here. So that means, well, that's the longest side, isn't it? So it's the hypotenuse. This 9 joins onto it, so it's the adjacent, and that makes the other side the opposite. So I have been given the adjacent and the hypotenuse, and I want x. So the ratio that includes the adjacent and the hypotenuse is that one there. Cosine. So let's write that out fully then. The cosine of an angle is equal to the adjacent divided by the hypotenuse. Okay, that's the full ratio that we need to use. So then let's sub in what we know. Cos, well, it's x in this case, not theta. Adjacent is 9 and the hypotenuse is 10. Okay, so the cos of x is 9/10. So then x is going to be the inverse cosine of 9/10. Okay, so that, reaching for the calculator, shift cos 9 divided by 10 comes out to 25.84, which we're just going to round off to 1 decimal place, 25.8. Question 11. A shape is made by joining a right angle triangle to a rectangle. Okay. And then we need to work out the area of the shape. Okay, so we've got 2 different shapes. We've got area 1, which is a triangle, and we've got area 2, which is a rectangle. Okay, so let's work out area 1 first. Area 1 is a triangle, so triangles normally have an area of half base times height. Now, base doesn't have to be the one on the bottom. Just your base and height need to be at right angles to each other. So I can use this side here as the base, and I can use this side here as the height because they are at right angles to each other, and so that would be perfectly acceptable for finding the area. So then that is going to be a half times 30 times 16, just subbing those values into my equation, and then half of 16 is is 8, and 8 times 30, 3 8s are 24, and a 0, and that's 240, isn't it? So that's going to have an area of 240 centimeters squared. What about A2? A2 is slightly more problematic because, well, it's a rectangle. It's got easy formula for finding it, but we only know one of them so far, don't we? We know this length here is 52. Okay, so one of them is going to be 52, but what is the other one? We don't actually currently know this one, do we? Okay, we haven't got that one. But you can see that that side there, which is going to be the width of this rectangle, is the hypotenuse of that right angle triangle, isn't it? So I can just use Pythagoras Theorem to find this one. Okay, so here I can use c squared equals a squared plus b squared, where a is 30 and b is 16. Okay, so what's that then? 30 squared plus 16 squared comes out to be 1156. Okay, so then c is going to be the root of that then, isn't it? Root answer, that's 34. Okay, so that means my hypotenuse is 34, so that's 34, so that's 34. Okay, so subbing that into my calculation here, 52 times 34, times that by 30, 52, going to get 1768. And so then the area is going to be those two things added together then, isn't it? So it's going to be 240 plus 1768. That comes out to be 2008 units, centimeters squared. Question 13. Outside a cafe, there is a large plastic ice cream cornet. The cornet is a hemisphere on top of a cone. The cone and the hemisphere each have a radius of 24 centimeters. The cone has a perpendicular height of 117 centimeters. Now we're handily given the formula for finding various things here. The volume of a cone, and interestingly the volume of the hemisphere. They've already halved it for us. That's very nice. And when we're asked to find the total volume of the cornet. Okay, so this is obviously not a real ice cream because this would be pretty huge. It's kind of a little plasticky one that's advertising the shop from the outside of the shop, isn't it? Okay, so then the volume we're looking for is made up of two areas. We've got the volume of the hemisphere and the volume of the cone. So we need to work out those separately and then add them together. So the volume of the hemisphere first. So the hemisphere formula is 2/3 of pi r cubed. So 2/3 of pi r cubed. Now we're told that the radius is 24. This gives it here. So that's going to go in there. Look. So I'm going to get 2/3 of pi times 24 cubed. Okay. Now I think that's going to be quite a big number. 24 cubed. What's that then? 13,824. I'm just going to divide that by 3 and times it by 2. That comes out to be 9216. So then the hemisphere in terms of pi is 9216 pi. I'm just going to leave the pi in for now because that will keep my answer accurate. Okay, if I try to actually sub pi in right as a decimal, I'm going to lose accuracy, and it's much easier just to write it down like that. Okay, right, let's move on and do the cone next. So the volume of the cone, that's 1/3 of pi r squared h. Okay, we already know that r is equal to 24, so it's pi times 24 squared. And h, where's h? H is 117 centimeters. Okay, so subbing that in for h. Okay, so subbed in r, subbed in h. And then just do the same thing. I'm going to tidy this up a little bit. So I'm going to do 24 squared times by 117 and then divide by 3. I'm not going to put the pi in yet. I'm just going to leave it in terms of pi just to make it a little bit easier to write down. So that's 22464 lots of pi. Okay. And now I need to work out the total volume of the cornet. So the total volume then is going to be the volume of the hemisphere plus the volume of the cone, which is 9216 pi plus 22464 pi, which comes out to be plus 9216. Oh, that's 31680 lots of pi. Okay, and at this point I'm going to multiply it through by pi. Times it through by pi. So that's 99,525.6. I'm just going to round off to 3 significant figures. So that's 99500 to 3 significant figures. And what's that? That's centimeters squared, isn't it? Centimeters cubed, sorry. So 99500 centimeters cubed to 3 significant figures. Part B says the actual cornets that the cafe sells are similar to the plastic ones. For the actual cornets, the cone and the hemisphere each have a radius of 2. How many times greater is the volume of the plastic cone cornet compared to the actual cornet? Okay, so we've got a big cornet and we've got equal cornet, and we know that this one is 24 and we know that this one is 2. Okay, and we're told that these are mathematically similar. Now, mathematically similar means they're exactly the same shape, not just a little bit like each other. It means they have the same proportions. So we've got the ratio of their lengths. So their lengths are in the ratio of 24 to 2 then, which is the same thing as 12 to 1. What we want to know is about their volumes. Okay, so the ratio of their volumes. And you can find the ratio of the volumes if you know the ratio of their lengths. All you've got to do is cube them. So that's going to be 12 cubed to 1 cubed. Okay, so 12 cubed is 12 to the power of 3. Comes out to be 1728. So that's 1728 to 1. Okay, and that just tells me then that the plastic cone is 1,728 times bigger than the cornet, the real cornet. So how many times greater is the volume of the plastic cornet than the actual cornet? It's going to be 1728. Question 13. The amount spent on clothes by 40 boys and 40 girls in 1 month was recorded. The table shows information about the amount spent by the boys. Okay, and I can already tell from the table, this is a group frequency table. So again, group frequency, they've got the midpoint marked, so I'm guessing they're going to ask me to find that estimated mean. The mean for the girls was £35. Estimate the mean for the girls as a percentage of the mean for the boys. Okay, so obviously the first thing I need to do is find what the mean for the boys is. So as I said, the table is already set up for it. To find the mean from a group frequency table, or estimate the mean, the first thing you've got to do is work out the midpoints of each of the groups or classes. That's because you don't know, out of these, for instance, these 22 boys here, you know that they scored between 0 and 20, but you don't know the precise value, do you, of what they got now, because the data's been grouped. So we use 10 halfway between them. 0 plus 20 divided by 2 is 10, as an estimate of what those 22 boys spent. Okay, so going down the list and working out the other endpoints, the midpoints. So 20 plus 40 is 60, divided by 2 is 30. 40 plus 60 is 100, divided by 2 is 50. And 60 plus 80 is 140, divided by 2 is 70. Okay, so they're the midpoints that I'm going to be using. So if I'm saying that 22 boys spent, well, I'm estimating £10 each, then between them, if I multiply those together, 22 times 10 is 220. Okay, I'm going to do that for each of my other values. 30 times 9 was that 270. 50 times 6 is 300. And 70 times 3 is, what's that, 210? Okay, adding that up, you can use your calculator if you like, but often it's easier just to do it in your head. So that's 0, and then 2, 7 and 1 is 0, carry 1, and I've got 2, 4, 7, 8, 9, 10. So that adds up to 1,000. Okay. You might want to double check it on your calculator, but I think that's right. So then the estimated mean then for the boys is going to be sigma fx which is this amount here, isn't it? The sum of the frequencies times their values, which is 1,000, divided by sigma f, which is this value here, the total sum of the frequencies. So 1,000 divided by 40. So what's that? I think it's 25, but let me just double check. 1,000 divided by 40, 25, yeah. Okay, so the estimated mean for the boys is 25. The mean for the girls was 35. Estimate the mean for the girls as a percentage of the mean for the boys. So if you're expressing one number as a percentage of the other, then the number that you are talking about first is the top number, and the number you're talking about second is the bottom number. So then the percentage, it doesn't look quite right here because it's a big one on the top, is going to be the mean for the girls, which is 35, divided by the mean for the boys, which is 25, and they're going to have to turn that into a percentage. Okay, so what's that then? So 35 divided by 25, that gives me 1.4, and times 100 is 140%. Okay, so the mean of the girls as a percentage of the mean of the boys is 140%. Oops, 140. Question 14. Olivia and Jessica have in total half as many sweets as Fran and Gary have in total. Fran and Gary share their sweets in the ratio of 2 to 3. Olivia and Jessica share their sweets in the ratio of 9 to 1. Fran got W sweets, Gary got X sweets, Olivia got Y sweets, Jessica got Z sweets. Find the simplest form of W to X to Y to Z. Oh my days, what's going on here? Right, okay, this is a bit complicated, isn't it? I think we're going to have to go through this a bit more slowly. Olivia and Jessica have in total half as many sweets as Fran and Gary have in total. So Olivia and Jessica have half as many as Fran and Gary. So what do we know? We know that Fran got W sweets and Gary got X sweets. So if I add W and X together, that is Fran and Gary's total, isn't it? Fran and Gary, that's those two. Olivia and Jessica had Y and Z. So if I add those together, I'm going to get Y plus Z. So those two together is that and that. I've got a feeling I'm just going to look at W to X to Y to Z and start putting some of this information in for me. So I know that Fran and Gary share their sweets in the ratio of 2 to 3. So Fran is W, so that's F. Gary is X. So Fran to Gary to Y is Olivia, and Z is J. So F to G to O to J, isn't it? Okay, and that's in the ratio W to X to Y to Z. So then Fran and Gary in the ratio of 2 to 3. So that's 2 to 3 there. And I know that Olivia and Jessica share their sweets in the ratio of 9 to 1. So that is 9 to 1. Okay. So altogether, these two here, look, is 5 parts. And these two together is 10 parts. Now we're told that Olivia and Jessica have half as many sweets as Fran and Gary. So these 10 parts actually should be as half as many as the ones that Fran have. So if they've got 10 parts altogether, then really Fran and Gary must have 20 parts, mustn't they? They must have twice as many. They should have 20 parts altogether because they've got twice as many as Olivia and Jessica. Okay, so that means we need to scale up our Fran and Gary parts by a factor of 4. Okay, so that means if I multiply the ratio of 2 to 3, I'm going to get the ratio of 8 to 12. Now that should then match with the other two, because now we're in the ratio of 10 parts to 20 parts, which is twice as many for Fran and Gary as Olivia and Jessica got. Okay, so this then should be the complete ratio: Fran, Gary, Olivia, Jessica, 8, 12, 9 and 1. So finding its simplest form, W, X, Y and Z, I think that's it, isn't it? Okay, can I simplify it down? I can't, because I've got a 1 on the end there, so I'm not going to be able to simplify it any more than it already is. Okay, so that is the final form: 8 to 12 to 9 to 1. Okay, question 16. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Okay, now the most popular way for this to be taught, I believe, is looking at second differences and using a kind of a convoluted way of piecing those two together. So the second differences here, for instance, are going to be 11, 21 take away 38 is 17, 38 taken away from 61, that is 23, and 61 taken away from 90, that is 29. Okay, and then so that's what we call the first differences. The second differences are the differences of the differences. So you can see that's 6, 6, and 6. Okay, so normally when people are taught how to do this, they're taught to find the second difference, take that value of 6 and halve it, and then that is going to give you your n term, 3n squared. And then you have to work out the rest. You have to kind of then work that out and take it away and all that sort of palaver. But actually there's a different way that you can do it that I want to show you. Well, maybe let's just finish this method off first, and then I'll show you the alternative way of doing it, which I think is nicer. So 3n squared. So if n is, remember this is when n is 1, n is 2, n is 3, n is 4, n is 5. Okay, so this sequence, if n is 1, 3n squared would be 1 squared times 3. It should be 3. When n is 2, 2 squared is 4 times 3 is 12. When n is 3, 3 squared is 9 times 3 is 27. And then 4, n squared is 16 times 3, 32, 48. And then 5 is 25 times 3 is 75. So then you work out the differences between your original sequence and this sequence for 3n squared. So what's that then? So the difference is 10 take away 3 is 7, 21 take away 12 is 9, 38 take away 27 is 11, 61 take away 48 is 13, and 9 take away 75, that is 15. Okay, so now what we've got left with, I hope you can see, is a linear sequence. So this has got a common difference this time. It goes up in twos, 2, 2, 2, 2, which means it's got to do with 2n. Okay, but it's not quite 2n, is it? Because 2n would be 2, 4, 6, 8, 10, and we've got 7, 9, 11, 13, 15. And that is 5 more than 2n. Okay, so then we combine these 3 bits together to work out that the nth term then of this quadratic, therefore nth term is 3n squared plus 2n plus 5. Okay, so now the reason I'm not so fond of this method is that, you know, y 3n squared minus, do you even know why you have to halve it there? It's just kind of learning a way of doing something. You don't really understand why it is what it is. Okay, well, that's the reason why I don't particularly like it. So we're basically teaching students how to do something. We're not teaching them why. When we're teaching this method, they rarely understand why you have to take the 6n, the common difference and halve it, and that gives you 3n squared. They don't really make the connection. So I tend to teach it a different way. I use it with the general forms of a quadratic. So if it's a quadratic sequence, then the general form of a quadratic is an squared plus bn plus c, isn't it? That's the general form of the quadratic, okay, where a, b, and c are some constants. Okay, now when n is 1, that's the first term of our sequence, isn't it? So when n is 1, then an squared plus bn plus c, I'm going to have 1 squared times a, that's a, plus 1 lot of b, which is b plus c. Okay, and I know that that is equal to the first term of my sequence. It's actually equal to 10. Okay, now when n is 2, then an squared plus bn plus c, an squared, take n, 2, and square it, 4. I'm going to get 4a plus bn, which is 2b plus c. That is equal to my second term. That is equal to 21. Okay, and then when n is 3, n squared is 9, so that would be 9a plus 3b plus c, and that is equal to our third term, which is 38. So what we do instead with this, we kind of, and that's, you just kind of stop there. What we're doing is we're forming 3 simultaneous equations in a, b, and c, which we can then go on and solve simultaneously. Okay, now you might think, oh, simultaneous equations is horrid. Why on earth would we do it this way? This is really complicated. But actually, this bit here is the same no matter what sequence, quadratic sequence you're given. You always get this. So the only thing that you have to do is kind of bolt on your extra terms that you've been given from the actual sequence to form your equations. And then the technique becomes very similar. So after you've done a few this way, it comes really, really easy. Okay, so I've got 3 equations in 3 unknowns, a, b, and c, which I'm going to go on and solve. So the first thing I'm going to do is going to take equation 2, and I'm going to subtract equation 1. So equation 2, this one, subtract equation 1, which is this one. So what's 4a plus 2b plus c if I take away a plus b plus c? So kind of taking those away, I'm going to get 3a plus b, and the c's are going to cancel, so I'm going to get 3a plus b, and that is going to be equal to 21 take away 10, and 21 take away 10 is 11. Okay, and then I'm going to do the same thing. I'm going to do equation 3 take away equation 2, so then I've got equation 3 is this one, equation 2 is the yellow one. So taking the blue one, yellow one away from the blue one, so then 9a take away 4a is 5a, and 3b take away b is b, and 38 take away 21 is 17. Okay, so now I'm left now with 2 equations in 2 unknowns. Okay, so that's my second step. And now what we're going to do is we're going to take one of those away from the other. So that's going to be in my equation 4 and my equation 5. And now I'm just going to take 4 away from 5. So equation 5, take away equation 4. What's that then? So equation 5 then is this one. Equation 4 is this one. So if I'm taking equation 5 and I'm subtracting equation 4, what do I get? That's going to give me 2a is equal to 6. So a is 3. Once I know a, I can then sub it back into one of either 4 or 5 here. So 3a plus b is equal to 11. So 3 lots of 3 is 9. 9 plus what is 11? That tells me b is 2. Okay, and once I know b, then I can sub all those back into the first equation. A plus b plus c is 10. So a plus b is 5, and then what do I have to add on it to get 10? It must be 5, so c is 5. Okay, so they're my solutions. A is 3, b is 2, and c is 5. Then going back to our original form, a squared plus b, an squared plus bn plus c, just got to sub those values in. Therefore, nth term is equal to 3n squared plus 2n plus 5. Okay, so this draws on your knowledge of solving simultaneous equations. You might think, ugh, that looks hideous, I don't want to do it that way. But I would recommend giving it a go, because it's always the same. When you're doing this, no matter what quadratic you're doing, you'll find that 90% of the method is the same for every question, and you just get quite good at doing it. Okay, so try it. You know, I'm not saying you have to do it this way, but I'm saying I think it's a better method, and students who do learn it this way tend to do quite well at it. So yeah, give it a go or not. Question 16. On a restaurant menu there are 22 dishes, of which 4/11 are gluten-free, 7 rice dishes which are all gluten-free, and 5 naan breads, of which 40% are gluten-free. This meal deal is on the menu. Choose one main dish, one rice dish, and one naan bread. How many of the possible meal deals are totally gluten-free? Okay, so let's work out how many gluten-free dishes we've got to pick from our 3 different choices. Now, if I've got 22 main dishes, of which 4/11 are gluten-free, 22 times 4/11, 22 divided by 11 is 2, times 4 is 8. So we've got 8 mains which are gluten-free. We've got 7 rice dishes which are gluten-free, because they're all gluten-free. Now 40% of the naan. What's 40% of 5? 5 times 40%. 40% is 4/10, isn't it? 40 over 100, 4/10, which is 2/5. Divide 5 by 5, times it by 2 is 2. It's going to be 2 naan breads, isn't it? Okay, so that means how many different choices are there? You've got 8 choices for your main dish, you've got 7 choices for your rice dish, and you've got 2 different choices for your naan dish, which altogether is, what, 8 times 7 is 56, times 2 is 112. I make that 112 separate choices which are gluten-free. Question 16. Here is a cube with edge length x centimeters. One diagonal is shown. Part A says circle the length in centimeters of the diagonal. Okay. Now, diagonals in cubes or cuboids come up often enough for you to remember the formula for it. There's a variant of Pythagoras Theorem for cuboids. So in 2 dimensions, and you've got a right angle triangle, you know that c squared equals a squared plus b squared, don't you? Where a and b are the 2 shorter sides of your triangle, and c is the longer side. So that's Pythagoras Theorem. Now when you've got a cuboid and you want to know the length of the diagonal in that, okay, there is a related formula. Let me just kind of show that a little bit clearer. Okay, so there's a related formula. It says the length of the diagonal, which I'm going to call d squared. So let's say this cuboid had length x, width y, height z. Then d squared then would be x squared plus y squared plus z squared, or d is equal to the square root of x squared plus y squared plus z squared. Okay, so like I say, it comes up enough, I would say, to memorize this really. You can do it just by applying Pythagoras Theorem twice. You can make a triangle here and work out the length of that hypotenuse after you have applied Pythagoras theorem to this triangle and worked out the bottom line there, because you've already got that one. So you can just apply Pythagoras theorem twice, but knowing the formula kind of jumps over all of that. You can just go straight to using the formula. So d equals root x squared plus y squared plus z squared. In this case, it's a cube, not a cuboid. So x, y, and z are all the same, aren't they? So what you've got here then for a cube, for the cube, where all the sides are the same, then d is going to be equal to the root of x squared plus x squared plus x squared, because all three sides are the same, which is the same thing as the root of 3x squared. So it is, which one? Now I don't see that one matched down there, but we can break this one up a little bit more. We can reformulate this a little bit. We can say that the root of 3x squared is the same thing as the root 3 and the root of x squared. So that is the same thing as the root 3 of x. So I believe it is that one there at the front. Okay. Not a nice way of writing it, but anyway, I prefer to write as the root of 3x squared, but yeah, on there it's that way around. 16b, the total length in centimeters of the edges of the cube is a multiple of 18. Circle the correct statement. X is a whole number, x is not a whole number, x might be a whole number. Okay, the total length in centimeters of the edges of the cube. How many edges does a cube have? Okay, let's just think about that. So if I've got a cube, better show all the sides, didn't I? Okay, so then how many edges does it have? It's got 1, 2, 3, 4 along that face, 5, 6, 7, 8 looking at the edges of that face, and then you've got 9, 10, 11, 12. So you've got 12 edges altogether. 12 edges. Okay. And 12 edges, if you add up the total length in centimeters of the edges of the cubes, you get a multiple of 18. Okay. Is x a whole number? Is x not a whole number? Is x might be a whole number? Okay, well, if the total is 18, okay, let's say that the total was 18, the first multiple of 18, and you've got 12 edges, then each edge is going to be 18 divided by 12. It's going to be 1.5. Okay, that's not a whole number, is it? Okay, so it's definitely not this first one here. It's definitely not a whole number all the time. But let's think about the next multiple of 18. The next multiple of 18 is 36. Now 36 divided by 12 is a whole number. That is 3. So that means it's not always not a whole number. It's that one. It might be a whole number. Okay, because I've got two examples there. One when it's not a whole number and one where it is, for two different multiples of 18. So that's going to continue, isn't it? The next multiple is not going to be divisible by 12, and the one after is. Okay, so x might be a whole number. Question 17. 20 people are asked which device they used more often, their laptop or their phone, and the table shows the results. For males, 2 used their laptop most and 9 their phone. For females, 4 used their laptop most and 5 their phone. I would contest that data, but anyway. 1 male and 1 female are chosen at random. Work out the probability that exactly one of them said laptop. Okay, let's first work out the probability of individual males and females saying laptop then. So the probability that a male says a laptop, that is going to be the 2 males who had laptops divided by the total number of males. Now, if you've got 2 with laptops and 9 with phones, that's 11 altogether. So the probability that a male says laptop is 2/11. Now, the probability that a female says laptop is the 4 who said laptop out of the total of 9. Okay. Now we know that, we want to work out the probability that exactly one of them said laptop. Okay, I'm going to do that in a little kind of tree, like a probability tree. So let's do the male choices first. So this is the male. and then we'll do the two branches for the female choices. Okay, so assuming that the male said laptop here and not laptop there, and laptop, not laptop, laptop, not laptop. Okay, so the probability that the male said laptop was 2 in 11. So the probability that the male didn't say laptop was 9 over 11. Okay, the probability that the female said probability that the female said laptop was 4 over 9. So the probability they didn't say laptop was 5 over 9. And that's going to be repeated down here because they're independent. Okay, so then we're interested in exactly one of them said laptop. So the probability of exactly one, that is going to be either that the male said laptop and the female didn't, or it's going to be that the male didn't say laptop but the female did. Okay, so it's those two branches, isn't it? So it's going to be the branch laptop, not laptop, or, which is plus in the land of probability. I'm just going to move this over because I'm kind of busting out the edge of the screen here. So let's just move this over to the side a little bit because I ran out of space. Let's just move it that way a little bit. Yeah, that fits better. Okay, so the probability of exactly one was probability of laptop for the boy, not laptop for the girl, plus the probability of not laptop, laptop then. Okay, so probability of laptop, not laptop, that's the yellow root. Okay, and that is going to be 2/11 times 5/9. And then probability of not laptop, laptop. So boy not laptop, girl laptop, that was going to be the green root. So that is 9 over 11 times 4 over 9. Okay, so what's that then? Calculator, what is 2/11 times 5/9 plus 9/11 times 4/9. That comes out to be 46/99. Part B says two males are chosen at random. Work out the probability that they both said phone. Now this is going to start out the same way, isn't it? With males either choosing laptop or not choosing laptop. In other words, choosing phone. Okay, and the probabilities are going to start out the same. We've got 2 out of 11, don't we, who chose laptop, and 9 out of 11 who didn't. But then on the second selection, remember that you've already picked one of the guys, haven't you, to ask. So then if you're going to pick again, you're going to have different probability outcomes depending on what happened first time round. So let's assume you picked one of the guys who preferred working on their laptop. When you ask the next set, you've got one less to pick from of people altogether, and one less person who chose laptop because you've already picked one earlier. And the same earlier for the second fraction, you're going to have out of 10 there, and you still got all 9 to pick from there. Okay, so then in the second route, if I pick not laptop first time round, I've still got the two guys who preferred laptops to pick from, but then that is out of 10, and I've got one less people who didn't like laptop out of 10 in that direction. So that's laptop, not laptop, laptop, not laptop. So then the probability of both phone, just one route through, isn't it, this time? That means not laptop, not laptop. So it's going to be the 9/11 times 8/10, which is what? 9 8s are 72, 11 10s are 110, sorry. So that's 72 over 110. Question 17. A, B and C are points on the circle, center O. BD is a tangent to the circle. OCD is a straight line. Work out the size of angle X. Okay. Now in order to work this out, I'm going to have to apply various circle theorems to this diagram. Now first up, I've been told that BD is a tangent to the circle. So that means that this line here, OB, which is a radius drawn at the point of contact, that needs to be at right angles to the tangent, because that is always a thing. So those two lines must always be at a right angle. Okay. Now the second circle theorem that I can use is the fact that the angle at the center is twice the angle at the circumference, like that. So that angle there being 32, if I double it up, then I'm going to get the angle here, which must be 64. Okay, so that angle must be 64. So then I found two angles in this triangle down here then, haven't I? Okay, and I know that the angles in the triangle add up to 180 degrees, and I know the other two, so I should be able to find X. So I should know that X plus my 64 plus the 90, my three angles in the triangle, add up to 180 degrees. So if I add those two together, so that's X plus 154 is equal to 180. So taking 154 away from both sides, then X is going to be 26, isn't it? So that's my answer. X is 26. Question 18a. I've got a Venn diagram here with an area shaded on it, and we're asked which of these represents the shaded region. Is it A? Is it B dash? Is it A intersect B dash, or is it A union B dash? Okay. Now this dash means not, doesn't it? So B dash is not in B. So clearly the area is inside A, but it's not all of A. And clearly the area is outside B, but it's not all the area outside B. It's going to be one of these two at the end, isn't it? It's going to be either A intersect not in B or A union not in B. Now another way of reading these intersections and unions is using the words and or. A intersect is the same thing as and, really. You can think of intersect as and. So is it in the set A and not in B? Oops. Or is it union, which we can read as or? Is it in A or in the or not in B? Well, I think it is this one. It's in A and it's not in B. Because if it was in A or not in B, it would also be this area around the edge here. That would be A or not in B. So not that one. It's A and not in B. In question 18b, I've been given another region on the same diagram, and again I need to find the correct set notation to use here. Now remember what I was saying earlier, that union is the same thing as or, and intersect is the same thing as and. Maybe that helps. So let's see if we can decode what some of these things that I've written down here. What is A union B? Well, A union B is the intersect of... No, it isn't. A union B is everything inside A or everything inside B. So then the not that then is going to be everything not in that intersect. It's going to be everything on the outside. So I think that's the one we want, isn't it? It's that one there. Let's just double check. A intersect B is just a bit in the middle, and then if I flip that round, that's going to give me everything on the outside plus that bit plus that bit. So the only bit that's left unshaded is a little teeny tiny bit in the middle. So it's not that one. Not in A intersect B. So not in A and in B. So that is just going to be that bit there, isn't it? Not in A intersect with B. And then this last region, not in A union, not in B. is the same as the one we had earlier, so not in A, union, so I can shade all that and I can shade all that, and it just leaves me that little bit in the middle again. So yeah, it's definitely that first one there, A union B dash. Question 18, show that for x not equal to 0, x plus 4 divided by 3x minus 5 over 2x can be written in the form ax plus b over cx, where a, b, c are integers. Now don't worry too much about this bit, they have to put that in there, otherwise you're going to get division by 0, aren't you? Because I've got x plus 4 divided by 3 lots of 0, which if you've ever typed in division by 0 into your calculator, know is undefined. So that is all just really excluding that as a possible solution, just so that you're not dividing through by 0. Right, so what we want to do is we want to take these two fractions and put them over a common denominator then, don't we? Now normally with fraction subtraction, that's what you do. You would take your two denominators, you would find a common denominator, and then scale up your numerators accordingly. And we're going to do the same thing here. So I've got x plus 4 over 3x minus 5 over 2x. And we need to find a common denominator. So I've got 3x and 2x. So what's common? Well, they both got x in it, so I can have x as part of my common denominator. And I've got the numbers 3 and 2, and so the lowest common multiple of 3 and 2 is going to be 6. So I'm going to use 6x then as a common denominator. So 3x goes into 6x twice, so I'm going to multiply up this one by a factor of 2 then, aren't I? So I'm going to get 2 lots of x plus 4, subtract, and my 2x goes into 6x 3 times, so I'm going to multiply this one up by a factor of 3. So that's going to be 3 lots of 5. Multiplying out the brackets on the top, 2 lots of x plus 4 is 2x plus 8. Don't forget to multiply the 4 by 2. Minus 15 all over 6x. So that's going to be 2x. 8 take away 15 is minus 7, isn't it? So there we go, 2x minus 7 over 6x. So that is of the form ax plus b is over cx, where a is 2, b is minus 7, and c is 6. So that is all fine. Question 19. In the UK in 2000, 25% of the population were under 24 years old, 50% of the population were 37 years old, and the interquartile range for the age was 32 years. The oldest person was 107 years old. Show this information on a box plot. Now, a box plot has a box in the middle and two whiskers and a line in the box like that. That line in the box is Q2, the median. And then we have Q1 and Q3, the upper and lower quartiles. And the whiskers go out to the highest and lowest values. So in order to draw this box plot, we need to know those 5 values there. So let's go through the question and see what it's telling us. 25% of the population are under 24 years old. Now, 25% of the way through a population is going to be the lower quartile. So this is actually giving us Q1. So Q1 is 24. 50% of the population were under 37 years old. So halfway through the populations are medians. Actually, they're giving us Q2 there. That's 37. Now the interquartile range was 32. Now the interquartile range is the distance between the upper and the lower quartile. So we can use our lower quartile 24 and the interquartile range to work out where the upper quartile is. 24 plus 32 gives us 56. So Q3 is at 56. Now the oldest person was 107 years old, so that's given us the maximum value is 107. And what's the minimum value? Because we need to have the lower whisker, don't we? Well, we're going to assume that the lowest person's age is just fractionally above 0. So we'll put that one in there. It doesn't give us any other information, so that's a natural assumption. Okay, so we've got all the data we need. We can now draw it on. So getting the ruler out, I'm going to draw a line at 24, 37 and 56. 24 is going to be my lower quartile. 37 is my median. And 56 is the upper quartile. You see there are 5 divisions between each 10, so they're worth 2 each. Okay, so just turning my ruler around, joining that up to make a box. And then I can add the whiskers on. So the whiskers go to my min value, so down to 0, and to my maximum value, so up to 107. Okay. So there we go. Job done. Part B says it is predicted that in 2050 the age distribution in the UK will have a lower quartile of 26, a median of 44 and an upper quartile of 66. Make 2 comments about the predicted change in the age distribution in the UK. So I think I want to do 2 comparisons between the 2 different types of data we've got here. A median is a measure of average, so I'm going to compare the medians. And interquartile range is a measure of dispersion, so I'm going to compare that as well. So what is the interquartile range? Interquartile range is going to be Q3, our upper quartile, minus Q1, our lower quartile, which is 40. Okay, so I'm going to be comparing the medians and the interquartile range. So let's look at the medians first. So my new median is 44, and from the first part of the question, my median was 37. So the median has gone up. So in terms of the age of the population, it means that people on average are going to be living longer. So median age has increased from 37 to 44. So people are older on average. And secondly, the interquartile range has increased also. So the interquartile range has increased from 32 to 40, meaning that, well, it means that there's more variation in the ages of people, meaning that there is greater variation in people's ages. Okay. 19a, the graph shows the speed of a vehicle during the first 40 seconds of motion. Calculate the distance travelled by the vehicle during the first 40 seconds. Okay. Now my graph went a bit weird when I printed it out, so I've just kind of quickly drawn on the numbers a little bit more clearly. Now let's have a think about the motion of this car. It's starting from 0, it's speeding up to 30. That's a period of acceleration, and then it's carrying on at the same speed for a number of seconds after that. So it's accelerating for the first 15 seconds, and then for the rest of the up to 40 seconds it's carrying on at a uniform speed. Now we want the distance traveled. Now the distance traveled is going to be the area under the graph. Okay, it's just a fact. Area under a speed time graph gives you the distance traveled. Okay, so what we need to do is work out what the area is under that diagram.
Now it's got those two sections, isn't it, where it's accelerating and then is uniform for a bit. So I'm actually going to divide the graph up into two parts, and I'm going to calculate the areas separately. I could just do it as a trapezium, but I'm just going to divide it up and do it as a triangle and a rectangle. Okay, so either is acceptable. You could just use the trapezium area formula, but I'm just going to use the triangle and the rectangle because it's a little bit easier. So the area is going to be the combination of those two areas, and isn't it? It's going to be like half base height for the triangular part plus the length times width for the second part there, isn't it? So half base times height. Now this triangle part has got, what is the base? The base is 15. And the height, this distance down here, what's that? That is going to be 30 then. So it's got a base of 15 and a height of 30. So that's a half times 15 times 30 plus length times width of the second of the rectangular part. So that's the length, isn't it? 15 up to 40. So that's got a length of 40, take away 15, that's going to be 25. So the length is 25. What is the height? It's going to be the same as the last one. It's going to be 30. Okay, so it's 25 times 30, isn't it? 25 times 30. So half of 15 times 30, or 15 squared, what's that then? That's 225 plus 25 times 30, 750 added together. 750 then added together, that is 975. What's the units? We've got meters per second and seconds, so that's going to give me meters then. It's 975 meters.
Question 22a. Amy drew this histogram to show the times taken to complete a task. You can see we've got frequency density down the side, and we've got time along the bottom. But what's interesting, I think, is that she's used a broken scale here, which is not really recommended for frequency density. Basically, you're taking a big chunk of the bottom half of the graph out, and it's going to make all the heights of those bars unrepresentative, really. So using a broken scale on a frequency density on a histogram like that is not really appropriate. You know, you can use a broken scale if there's no data along the time. We could have broken a scale and started around about 5 on the time axis without too much damage, but not on frequency density. That's not going to work. So using a broken scale for frequency density, gives a misleading picture of frequency. Okay, second part. Here is another histogram showing the times taken to complete another task. Okay, this time we haven't got a broken scale. Estimate the percentage of people who took less than 30 seconds. So less than 30 seconds, let's just get the ruler out. So less than 30 seconds is going to be everybody to the left of this line, isn't it? So if I can work out the area of those 3 bars and add them up, I should be able to work out the frequency. So this first bar has got a height of 40, frequency density of 40, and it's got a width of 10, so that represents 400 people. The middle bar has got a height of 25 and a width of 10, so that represents 250 people. And this part of this bar here has got a height of 20 and a width of 5, representing 100 people. So my estimated percentage of people who took less than 30 seconds. Well, the number of people is going to be those three bars added together. So 400 plus 250 plus 100, which comes to 650, 750. So then that is a percentage. So percentage is going to be 750 out of how many people took the test. Does it tell us? No, that's annoying. So now we need to work out what the rest of the bars are, so we can work out what it is as a percentage. So that's the number of people less than 30. So now we need to work out what the total is. Well, the total is going to be the other bars then. So if I then add up the other ones, okay, so this one has still got a height of 20 and it's got a width of 15. So what's that? That's 300. And then this one has got a height of 10 and a width of 5. So that's 50. So then the total is going to be my 750 plus 300 plus 50. So it adds up to 1,100. So then my percentage is going to be my 750 divided by the 110 times 100%, which is 68.2%. Question 23. In triangle JKL, M is the midpoint of JK. Jn to NL is in the ratio of 3 to 2. And we're told that the vector KL is 7a and the vector N to L is 4b. Okay? Work out the vector J to M in terms of A, B. Give your answer in its simplest form. So what we need to do is we need to find this vector here then, isn't it? Okay? We need to find that one. What do we know? We only know this direction here and we know this direction here. So basically what we're going to have to do is to find J to K and then halve it to find J to M. Okay, I think that's what we're going to have to do. Now we've got some information up here that isn't in the diagram. First off, we've got that M is the midpoint of JK. So that means that this distance is the same as this one then, isn't it? Okay, so let's just mark that on. And we're also told that Jn to NL is in the ratio of 3 to 2. So Jn to NL, so this is 3 to 2 along here. Okay, so if this is in the ratio of 3 to 2 and NL is 4b, then if I divide that by 2 and times it by 3, it should tell me that J to N then, this part down here, is going to be 4b divided by 2 times by 3. It's going to be 6b, isn't it? That's going to be 6b. I'm just going to write that down. That if I've got, if N to L is 4b, and I know that J to N is 3/2 of 4b, then I know that J to N is 6b. And that tells me also that J to L is going to be J to N plus N to L, which is going to be 6b plus 4b, which is 10b. Okay, so I know J to L is 10b. I already know K to L is 7a. So then I can find an expression for J to K. So this distance all the way along here. Well, going the other way actually. So what is the vector JK then? Going along places that I know. I can't go direct because I don't know anything about that line yet, but I know the other route. So I know that I can get from J to K by going from J to L and then going from L to K. Okay,
And I know that j to l is 10b because I just found it. And I know that L to K is going to be minus 7a, okay? Because I'm going against the arrow, aren't I? So it's negative. Okay, so j to K is 10b minus 7a. Now, what we want to know is what Jm is. And we know that Jm is the midpoint of Jk. So j to m is going to be half of the vector j to k then, isn't it? Okay, so that is going to be half of 10b minus 7a, which is going to be, just multiplying that out, I'm going to get 5b minus 7 over 2a, like, just going to write it like that, 7 over 2a, it's like 3.5a. So the vector I want, j to m, is 5b minus 7 over 2a. Question 24. Work out the coordinates of C when ABCD is rotated 90 degrees clockwise about O, then translated by minus 6, 2. Okay? If you're not so good with rotation, it's probably best to do this with tracing paper. Just lay your tracing paper over the shape, then trace your shape out, and then hold down your pen at the origin and turn it 90 degrees clockwise. Sometimes helps to do a little cross in the center so you can keep track of how far you're meant to turn. If you do that, you should find that B ends up here. C is going to end up down here. A is going to end up here. And D is going to end up down here. Okay? If you get good at it, you can do it without tracing paper, but you have to be pretty pro, I think, in order to do it. Then join them up with a straight line. Okay, so that's going to be my shape after the rotation. So that is C dash, B dash, A dash, D dash. Okay, and then I'm going to translate it by minus 6, 2. Now, minus 6, 2. The top digit is in the direction of x and the bottom digit is in the direction of y. So I need to go negative 6 digits in the direction of x. That means I'm going to go 6 units to the left and 2 units in the direction of y, which is 2 units up. Okay, so taking the point B to start with, I'm going to be going 1, 2, 3, 4, 5, 6 to the left, 1, 2 up. I'm going to end up at that point there, aren't I? Okay. Let's get rid of that. So that's going to be my B dash. So it's going to be B double dash. B double dash. Do the same thing with C. So if I start at C and I go 1, 2, 3, 4, 5, 6 to the left and 1, 2 up, takes me to that point there. That's going to be C double dash. Okay, and then A. 2, 4, 6 along, 2 up, takes me to here. Okay, that's going to be A double dash. And then finally D. 2, 4, 6 along, 2 up, takes me to there. Okay, so that then is D double dash. Okay, and again I'm going to join them up into a shape now. Now I've found all the corners. Okay, and that is my new shape. So remember, we needed to work out the coordinates of C. So now C is over here, isn't it? What coordinates is that then? So then the coordinates of C double dash is going to be minus 5, comma, minus 2, and is it negative 5, negative 2. Question 25. The time of each swing of a pendulum, length L centimeters, is t seconds. T is directly proportional to the square root of L. When L is 64, T is 1.6. Work out the value of T when L is that number there. Okay, so let's start off with the proportionality. We are told that D is directly proportional to the square root of L. So let's write that down. T is proportional to the square root of L. Next step, we can replace that proportionality with equals k lots of root L, like that. We're told a pair of values that link L and T together, which we can use now to evaluate k.
So when L is 64, T is 1.6, which means that 1.6 equals to K lots of root 64. So the root of 64 is 8, so 8K is equal to 1.6, and then dividing both sides by 8, we're going to get 0.2 is equal to K. So therefore our complete equation is T is equal to 0.2 lots of root L. Now we know that, we can work out the value of T when L equals 132.25. So when L equals 132.25, just sub that in. T then is going to be 0.2 lots of the root of 132.25. So reaching for the calculator, 0.2 times root 132.25 gives me 2.3. So T is equal to 2.3.
Question 28. A equals 4.72 to 3 significant figures. B equals 1.58 to 3 significant figures. Work out the upper bound of A over B. You must show your working. Okay. Now when I'm doing these limits of accuracy questions, I like to draw a number line and mark on the number they give me. So that is 4.72. Now, that's been rounded to 3 significant figures. Now the third significant figure is that 2 there, which is in the hundredths column. So 1/100th more than 4.72 would be 4.73. So one number up on my number line is going to be 4.73. 1/100th down would be 4.71. So then the numbers that are going to round to 4.72 are going to be like halfway between those or closer, aren't they then? So this range of numbers here. Okay. So the lower bound for A is going to be 4.715 because that's halfway between 4.71 and 4.72. And the upper bound is going to be 4.725 because that's halfway between 4.72 and 4.73. Okay, now that's A. I'm going to do the same thing for B. B is 158 to 3 significant figures. So I'm going to draw another number line. I'm going to mark on the number they gave us, which is 158. Now this time the third significant figure is that 8 there, isn't it? 1, 2, 3, it's the 8. So that means this number's been rounded to the nearest unit or whole number. So one whole number up from 158 is going to be 159. One whole number down from 158 is going to be 157. So that means that the numbers that round to 158 are going to be halfway between those or closer. So this range, all these are going to round to 158. That lower bound there is halfway between 157 and 158. That's going to be 157.5. And the upper bound is going to be halfway between 158 and 159. That's going to be 158.5. Okay? Right. Now we need to work out the upper bound of A over B. Okay? So we've got two possible values of A that we're going to use. We're going to use the upper bound and the lower bound. And then we've got two possible values of B. And we want to pick the values of A and B that are going to deliver us the largest value of A divided by A divided by B. So A divided by B, what's that then? Now to get that as big as possible, I'm going to pick the biggest value of A that I can, which is that one, isn't it? Okay, I'm going to pick my biggest A, which is 4.725. And I'm going to divide it by, now, do I want the biggest or the smallest value of B? If I pick the biggest one, I'm going to divide A by a bigger number and I'm going to get a smaller result. Then if I divide it by the smaller one, I'm going to get the bigger result, aren't I? So I'm actually going to use the lower bound of B, because that is going to deliver the largest value overall for A over B. Now if you can't figure these out,
The alternative is just to try all the various combinations. There should be 4 combinations altogether. Try upper with upper, lower with lower, upper with lower, lower with upper. You just work all 4 of them out and then you see which one delivers you the bigger one. I'm pretty good at reasoning it out, so then I'd rather spend the time reasoning and do the calculation once. But if you're not able to reason it out that way, then like I say, the alternative is just to work out like a brute force attack. Just work all 4 out and then you see which one is going to give you the biggest number. Right, I'm pretty confident this will though. So 4.725 divided by 1.57.5, that comes out to be 0.03. Okay, so that is my upper bound. So that is my upper bound of A over B. It's 0.03. Okay. Question 28. F of x equals 5 minus x and g of x equals 3x plus 7. So we're asked to simplify f of 2x plus g of x minus 1. Okay, so basically when you've got something inside the bracket, that is the value that you're given to x. So here f of 2x is going to be 5 minus, going to sub in 2x for x. So that first part is going to be 5 minus 2x. And then plus g of x minus 1. Where I see x, I'm going to write x minus 1. So I'm going to write x minus 1 in there, just like I wrote 2x in there for the first one. So 3 lots of x, which in this case is x minus 1, plus 7. Okay, so simplifying that, I've got 5 minus 2x, multiplying out the brackets, plus 3x minus 3 plus 7. Collecting like terms, I've got minus 2x plus 3x, which is x. And I've got 5 plus 7, which is 12. Take away 3, which is 9. So x plus 9. So it simplifies to x plus 9. Question 28b says solve g to the minus 1 of x is equal to 2x. Now g to the minus 1x is the inverse function. Okay, now we learned earlier that g of x was 3x plus 7. So if g of x is 3x plus 7, and we want to work out what g to the minus 1 of x is. Now let's take that equation 3x plus 7, or that function, and put it equal to y. I'm going to rearrange it for x and then reform the inverse function from that. So 3x plus 7 is equal to y. Let's subtract 7 from both sides. You're going to get 3x is equal to y subtract 7. And then dividing both sides by 3, I'm going to get x is equal to y minus 7 over 3. Okay, so I've made x a subject. So from that, I can tell that the inverse function g to the minus 1 of x is going to be equal to, I'm just going to take this expression here, y minus 7 over 3, and I'm going to rewrite it, but with that one replaced back with an x. So I'm going to write x minus 7 over 3. Okay, so that's my inverse function g to the minus 1 of x. Right, now we're told in the question, or we're asked in the question, to solve g to the minus 1 of x is equal to 2y. So I'm going to take this expression I've just made for g to the minus 1 of x and equate it with 2x. So x minus 7 over 3 is equal to 2x. Okay, now we just need to solve for x. So multiplying both sides by 3, I'm going to get x minus 7 is equal to 6x. Subtracting x from both sides, I'm going to get minus 7 is equal to 5x. So then x is going to be minus 7 divided by 5 then, isn't it? Question 29. A shape is made up by joining a triangle ABC to a semicircle with diameter AC. Work out the total area of the shape. So what we're going to have to do, we're going to have to find the area of the semicircle and the area of the triangle and add them together. So the semicircle area is going to be fairly straightforward, you'd think, wouldn't it? Because the area of a circle is pi r squared over 2. So we need to work out what pi r squared over 2 is, but that means we need to know what r is, and we've not been given r. So we're going to have to work out what r is. So r is going to be half of this diameter here, so we're going to have to find the line AC. Okay? Now the other area, the area of the triangle, is going to be fairly straightforward because it's a non-right angle triangle where we know 2 sides in the included angle. So that one, that one's fairly straightforward actually. We can just use the trigonometric formula for area of a triangle, which is area equals a half AB sine C. Okay, we know everything in there, so we can work that one out, no problem at all. That's going to be a half times A, which is 8, times 10, which is 10, and times the sine of 114. So that's just tap it into the calculator and find out what the answer is. That's the easy squeezy bit. So half times 8 times 10 times the sine of 114. Okay, that comes out to be 36.5. I'm going to write an extra digit down because I'm going to round it off later. So I'm going to write down 4 digits and I'll drop down to 3 later. Okay. So that's that bit done. Now the next thing we need to do is know what AC is. So we want to find the third side of a non-right angle triangle, given the fact we know the other 2 sides in an angle. This is clearly a job for our trigonometry and non-right angle triangle rules, but is it the sine rule or is it the cosine rule? The sine rule tells us about opposite pairs, and the cosine rule tells us about 3 sides. Okay, so this one is about 3 sides because we've got 2 sides, we want a third side, so it's going to be the cosine rule. So using cosine rule, which states that we want B, don't we? This is side B. We label out the sides opposite the angles. So this is going to be side A, and this is going to be side C. So we want B, and so the cosine rule says B squared equals to the other 2 things squared, A squared plus C squared, minus 2 lots of the other 2 things multiplied together, multiplied by the cosine of your angle. Okay, so that's what we're going to do. B squared equals A squared plus C squared minus 2AC cos B. Now, sub in. A is 10 squared. C is 8 squared minus 2 lots of 10 lots of 8 times the cosine of 114. Okay, now I tried to do as much of this by hand first because I think you're more likely going to make a key in area on your calculator with the complex thing than you are by squaring 10. You should all know that 10 squared is 100 and 8 squared is 64, and you should be able to multiply 2 times 10 times 8 in your head. That's 160. So just do the maths that you can in your head that's easy to do, because it doesn't take very long, and like I say, you are more likely to make a key in area in a horrendous long calculation you have to type in your calculator than you are doing some basic maths, which, given that you're a top set, you're a higher tier student, you should be able to cope with. Right, so 164 minus 160 cos 115 then. So I've made it super easy for me to type that in, because I've done all the maths along the way and reduced it down as much as possible. That comes out to be 229 and change. Okay, but don't forget you need to square root that. It's the square root of 229 and change. I'm just going to write that down, but I'm going to square root my whole value. So square root answer 15.14. I'm going to write it down to 4 significant figures first because we haven't quite finished. And then I'm going to say then, so that's my length B, and then, so now I know what AC is, which is the diameter, so then my radius is going to be half that then, isn't it? It's going to be divided by 2,
So that's 7.568. 7.568. Okay, and now we can find the area of the semicircle then, can't we? So then the area of the semicircle is going to be pi lots of 568 squared over 2, which is equal to, so that thing squared divided by 2 and times by pi. I make that 89.96. So then I've got the area of the semicircle, got the area of the triangle, so then the total area is going to be those things added together. I feel like I'm on a roll. 89.96 plus 36.54. What's that then? Plus 36.54. Now I'm going to round it off to 3 significant figures. I was keeping it to 4 significant figures as I was going through, so that when I could drop down to 3, I'm not going to lose too much accuracy along the way. So 126 units squared centimeters. Question 30. A sphere has radius r centimeters. An approximate value of r can be found using the iterative formula Rn plus 1 equals the root of 239 divided by Rn. The starting value is R1 is equal to 7. Work out the values of R2 and R3. Okay, so what I like to do with these is I like to type in the first value into the calculator and then press equal, so it's the last stored value. Okay, and then I'm going to get the next value by taking the square root of 239 divided by Rn, which I'm going to use the answer key. So basically the last calculated value is going to come back and go into there. Okay, so R1 we know is 7, then R2 is going to be the root of 239 over 7, and I'm just going to press my answer key and find out what that is. That's equal to 5.843. I'm just going to write it down to 4 significant figures for now. 5.843, and then R3 we're going to get. All I need to do now is I'm going to write it out. So that's going to be 289 over 5.843. But because we the way we set it up on the calculator, all I have to do is press the equal button again, and it's going to feed in R2 into the formula, and it's going to give me R3 straight away. So that's 6.395. And again, we're just going to write down the first 4 significant figures for now. So that's 6.395. Okay, so we're done with that. Part B says continue the iteration to work out the radius to 1 decimal place. So basically we're just going to have to keep on finding more and more values until it settles down on the first decimal place and we start getting the same answer over and over again. So we've already got R3, so let's go on to find R4. Now again, I'm just going to press the equal button. That's going to feed in my R3 value and give me the R4 value. And again, I'm just going to write down the first 4 significant figures, 6.113, and I'm going to keep going until it settles down. So then the next one, R5, is equal to 6.253, and then R6 is equals 6.183. Still jumping around a little bit and wait until it settles down. R7 equals 6.218. Still bibbling between 1 and 2. Next one, R8 equals 6.200. R9 equals 6.209. And R10 is equal to 6.2. It seems to have settled now, doesn't it?
204. So the last digit is still kind of resolving itself. And then I've got R11 is 6.207. And then the next one. And if I keep pressing it now, I think I'm just going to keep pressing it now. Can you see it just kind of resolves to 6, goes down to 6.2058. Just going to round off to 6.206. That's where it kind of settles to. Okay, so then you can see that to one significant figure actually settled pretty quickly. It settled on the 6 from the first, well, from the second, from R3, didn't it? And then it started being 6, but it didn't really settle on the second decimal place until we got to R7, R8, and then it stayed being 2. Okay, and then you can see then we started getting the third decimal, the third significant figure there, and it took a little bit while longer for the fourth digit to settle down. But we just want to know what the radius is to one decimal place. So that is equal to, so the radius is equal to 6.2 to 1 dp.
Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.